Hi, welcome you all in this session of lecture in making a relation between moment of inertia and other physical quantity. So first suppose there is a displacement x of a particle in time t. So the differentiation of this quantity x with respect to time gives you the velocity, means the rate of change of position with respect to time is the velocity. If you differentiate it again, then the second order differential of this position x with respect to time gives you the acceleration, and acceleration is nothing but the rate of change of velocity with respect to time. So this can be written as d by dt dx upon dt is equal to a, and at the place of dx by dt we can put v equal to a, and that represents the rate of change of velocity with respect to time, and this is nothing but the acceleration in the body. So in the same case, if the particle displaces by an amount theta in time t, then the differentiation of this quantity theta with respect to time t gives you the angular velocity. Here the angle, rate of change of angle gives you the angular velocity omega. And if you differentiate it again, we have d2 theta upon dt square, and that is nothing but the angular acceleration alpha, and the acceleration is nothing but the change in the angular velocity with respect to time t. The rate of change of angular velocity gives you the acceleration. So d dt of d theta upon dt is equal to alpha, and at the place of d theta by dt we can place the value omega, d by dt omega equal to alpha, and it represents the rate of change of angular velocity with respect to time, and this is nothing but the angular acceleration alpha. Now if you consider a particle moving in a circular orbit on a circular path from a point P to point Q, and displaces by an amount x on this circular path. So this circular path is nothing but an arc, and this arc subtends some angle theta at the center of the circle. The radius of the circle is r smaller. Then by the relation of angle theta is equal to arc upon radius, the arc is nothing but x upon r. So the value of x equal to theta into r, and if you differentiate it with respect to time, we have dx upon dt is equal to, since r is constant, so the theta only be differentiated, then we have d theta upon dt, and this gives you the velocity, linear velocity, and this gives you the angular velocity omega. So this is the relation between the linear velocity and the angular velocity. So we have many relation with the moment of inertia. So how it relates? Now see it. The angular momentum L is nothing but the product of the radius vector r into the linear momentum p. Now differentiate it also. So we have dl upon dt is equal to r into dp upon dt. Here r is constant, so this can be treated as a constant and can take outsider from this differentiation. So we have here dl upon dt is equal to r into, and this is the rate of change of momentum with respect to time, and it gives you the force, linear force. Now what is this? This r into f, this is the torque, the tau produced in the body. So the rate of change of angular momentum gives you the torque, while the rate of change of linear momentum gives you the force. Now again from the relation L equal to r into p, at the place of p we can write mv, and v can also be changed omega into r. So this becomes mr square and omega, and L is equal to, here we have I into omega. So this is the angular momentum L in terms of moment of inertia. That the torque tau is equal to R into F, and the force F is replaced by ma. But what is the value of A in terms of angular acceleration? So the value of this A can be find out. V is equal to omega into R. Differentiate this equation. On differentiation, we get dv upon dt is equal to R is constant here, so we have only R into d omega by dt. What is this? This is the rate of change of a linear velocity, which is nothing but the acceleration A, and this is the rate of change of angular velocity, and is called angular acceleration alpha. So we have the relation A equal to R into alpha. So we can put the value of A here. At the place of A, we can write R into alpha. So this becomes now mr square and into alpha. And we have studied before that this mr square is nothing but I, moment of inertia of a rigid body, into alpha. So we have the relation tau equal to I into alpha, and the relation between the moment of inertia I and the force of rotation, that is torque.